Okie doke. On this side of the assignment, I'll work through the even problems. So we're solving inequalities. Inequalities work very similar to equations. The objective is to get the variable by itself, but you also must graph the solutions because there's not only one. Sometimes there's multiple solutions. So the first thing I would do on number 16 is add 16 to both sides of my inequality. Which would give me negative 8r greater than or equal to 16. Now we're going to divide by negative 8 on both sides to get r by itself. So you would have r, and then notice it says greater than right now, but because I'm dividing by a negative number, negative 8, that sign will change directions and turn to a less than or equal to. And then 16 divided by negative 8 is negative 2. So that's our solution. To graph it on the number line, we're going to put a closed dot at negative 2. It's closed because the equal to bar is present. And then we're also going to shade to the right. It works best if you have color pencils or a highlighter to do your shading so that it stands out. Number 18. On number 18, we have the variable on both sides of the inequality. I highly recommend moving the variable to the left side. Anytime you're dealing with an inequality, move the variable to the left. So that means I would subtract 3u from both sides, which leaves me with 1 minus 11u less than or equal to negative 10. Notice all the signs are brought down according to what they were originally were. And then for my negative 8 minus 3, you technically add those two negative numbers, and that's why you get a negative 11. Next, I would subtract 1 from both sides. I'm subtracting 1 because my u's have dominated and taken over the left-hand side. So that means all the numbers need to move to the right-hand side. So that leaves me with negative 11u less than or equal to negative 11. And now we're going to divide both sides by negative 11. And again, I'm dividing by a negative, so my inequality sign changes directions. So I'm going to have u is greater than or equal to a positive 1. Again, whenever you divide or multiply by a negative, change the inequality sign to the other direction. So on positive 1, I'm going to have again a closed dot because of the equal to. But this time, since it's greater than and it's pointing right, I'm going to shade to the right. On number 20, the first thing I would do is distribute. So I would distribute the 5 to x, so 5x, and distribute the 5 to the 8, which would give me a negative 40. Bring down the positive 1, my inequality. And then on the right hand side, I need to distribute the negative. throughout the parentheses. So then it become, I'm sorry, I forgot my 2. 2, and then minus x minus 5. So whenever you have a negative outside parentheses, you must distribute it to everything in there just like if it was a normal number. Technically, it is a normal number. It's negative 1. Now, the next thing I would immediately do is combine 1 and negative 40, which gives me negative 39 on the left-hand side. On the right-hand side, I have 2 and negative 5, which would give me a negative 3. And then bring down my x terms exactly the way they are. So 5x less than or equal to, and then negative x. Now again, we have x's on both sides of the inequality. So I'm going to move all of them to the left-hand side. So that means I'm going to add x to both sides, which would leave me with 6x minus 39 less than or equal to negative 3. Now I would add 39 to both sides, which leaves me with 6x less than or equal to a positive 36. And last but not least, I would divide both sides by 6. Does my inequality sign change this time? No, it doesn't, because I didn't divide by a negative. So it's x less than or equal to 6. Now we graph that solution. Again, it's a closed dot on 6. And since it's less than and pointing to the left, we shade everything to the left. For number 22, we're going to define a variable and write an inequality, then solve. So it reads 4 times the sum of twice a number. So we need a variable for number. You can say x or n or whatever letter you choose. So I'm going to say x. Keep it to something you're familiar with. When you say sum, that means there's some addition going on. Twice means to multiply, so we're twicing a number, so that's 2 times x. It says 4 times, so that means we're going to be multiplying 4 with something. So it's the sum of twice a number and negative 3. So 2 times x minus 3. And we're multiplying that with 4 because it's 4 times the sum of a number and 3. Sum of number and 3. Or sorry, negative 3. Is, again, is means equal. Or I'm sorry. The sum of the number is less than. Sorry, I need to finish it off. Read the whole problem to me, Michelle. So is less than. So that means less than, just like that. 5.5 times that same number. So x was our number, and we're taking 5.5 times x. So it would be 5x on this side. Now we're going to solve this inequality. So the first thing I would have to do on the left side is distribute the 4. So 4 times 2x is 8x. 4 times negative 3 is a negative 12. Bring down my less than and 5x. So I have a variable on both sides, so we're going to move 5x to the left because we always want our variables on the left. So that means subtract 5x. When you subtract 5x, that leaves you with 3x minus 12 is less than 0 because 5x minus 5x is 0. So you still have to have something over there, even if it's 0. The next thing I would do is add 12. That would give me 3x is less than 12. Then divide both sides by 3. And your final result would say x is less than 4. If I were to graph it, I would use an open dot because the equal bar is missing from the inequality symbol. And I would shade to the left because it's less than. When it's less than, you shade left. And number 24. Jan's account balance is $3,800. Of this, 750 is for rent. Jan wants to keep a balance of at least 500. Write and solve an inequality describing how much she can withdraw and still leave enough rent and a $500 balance. So we know her balance has to be at least 500. So at least means it needs to be less than or equal to, I'm sorry, greater than or equal to 500 because we don't want anything less than it. Sorry. So greater than or equal to at least and 500. So her balance is starting off with 3,800. So that's where we start. That's how much money is in the bank right now. We know that we have to pay rent $750. So we're going to take that out of our bank account, 750. And we want to know how much else she can withdraw and still leave enough. So we need a variable for the withdrawal. So we'll say minus W to represent our withdrawal. So I started with 3,800. I must take away 750 for rent. And then W represents however much money is left in the account after I pay for rent. So now I can solve my inequality. So I would first take 750 from 3,800 and we would get, I'm having a brain freeze, so let's type it in. 3,800 minus 750. 3,050 minus W greater than or equal to 500. So the next thing I would need to do is subtract 3,050 on both sides. would leave me with negative W is greater than or equal to so 500 minus 3050 negative 2550. And then the last thing I would have to do to get W completely alone is to divide by negative 1 on both sides. So I would have W, and then my inequality sign changes, so it turns into less than, and then it'll be a positive 2550. So she cannot withdraw more than $22,550 in order to maintain about $500 left in her accounts. If she goes over that amount, she will have less than 500. I hope that makes logical sense. And this concludes your tutorial. Good luck on completing your assignment.